Some thoughts on the Cartesian plane and something that I think about when I have time. This is a very rudimentary drawing of what the plane represents and some of my thoughts that I'll get to in a bit. So the Cartesian plane, I believe the concept is the concept comes directly from Rene Descartes, and I've been sick over the weekend, so my voice is a little croaky, and but the concept comes from Rene Descartes, and it's a pretty brilliant insight to be able to plot something on a plane with two axes in order to be able to not just pinpoint where a particular point should reside in terms of the 2D or the plane that is enabled, but tying this with algebra and geometry, and I think this is a very it's truly a remarkable insight in the world of mathematics, and it's something very simple. We probably take it for granted today, but from the perspective of, and this is all of what I say is very these are my uneducated thoughts, and I haven't really thought about this too much, but to me it just seems like a very remarkable insight that Descartes came up with. It's just a brilliant, I don't know how he actually thought about it for an extended amount of time, it was a flash of insight, whatever it was. It sounds like Descartes is the kind of guy who would like me, I think, I'm not sure, he liked to think about the ideas that he was working on over perhaps a period of time, which is, I guess, quite typical for individuals who do thinking in a sustained manner in respect to, I guess, outcome thinking. But that's not a conversation. I want to focus on the Cartesian plane, because again, the insight to be able to map something on a plane to what was going on in the world of, it had gone on in the world of algebra and geometry. Up until that point, nobody had come up with that system, and Descartes was the first person to have done that, and that is remarkable. It ended up revolutionizing mathematics, and we just keep gaining and benefiting from that one evolution or that one breakthrough, if you want to call it. Virtually every system that we use today, it has some kind of a Cartesian plane model built into it, specifically when it comes to mapping something, whether it's the UI in this computer or whether it's keeping track of the planes in the sky, or even just traffic regulation management. Conceivably, these are just some examples that come to me at the top of my head, but anything that needs to be located in a particular finite way, that's one use case, and a very useful use case or example that the Cartesian plane is. But it also is not just for pinpointing information or like something, an object or whatnot. It's also a way to enable newer realities, because if you take the same Cartesian plane and you then, right now it's kind of like it's kind of going in like these four, it's up, it's the y-axis and the x-axis. So, but you can actually, if you look up 3D Cartesian plane, this is how they actually, it looks a little weird, but this is how he actually represented, and that's a Cartesian plane in the third dimension. So you have another dimension emerging, which I believe is called the Z or Z axis. And I believe that I haven't done too much any research on that, what I'm about to say next, or this and that, but that enables a whole reality that you can play in, and I believe that is leveraged, particularly in the world of computer animation or anything that requires a representation of the 3D reality that we inhabit, and in order to be able to recreate that in diverse and intricate set of ways. So to just kind of focus on the actual breakthrough or the insight, again, it is a genius ability to be able to map numbers in a way that precisely tie this construct, this ability to be able to represent numbers in a way that ties algebra and geometry together. And I believe the Cartesian plane was the first enabler when it comes to linking these two realities. I could be wrong, but it seems like a very, very interesting breakthrough. Now, I want to take a bit of a diversion from Cartesian plane, and it was kind of like thinking about this, and so so I'm just going to show that for a second and just talk about this for a little bit. So anything that we're trying to make sense out of can probably shift at this point. Whoops. Anything that we're trying to make sense out of, I don't know much about the scientific principle, but what you want to do is measure it in a controlled environment. And from that perspective, precepts grounded in the Cartesian plane are generally leveraged. So you want to understand something, you measure it. And I don't know what different kind of systems for measurement actually exist, but every time I've tried to kind of get into the basics of any component, whether it's something in a celestial sense or something in a biological sense or something in a, I don't know anything about quantum, so I'm not going to talk about that, but generally speaking, it seems like the matrix that is enabled, it's seems like a Cartesian plane kind of a reality. So starting with the GPS system, you have longitude and latitude, and you have points on the coordinate systems whereby you can ascertain where a particular point on Earth really resides, and from that we create maps and navigation systems that rely on those maps and all these other amazing and interesting things. So that's one example. It's the same with the night sky. When you are mapping something in the sky, whether it's some object like an asteroid or in some orbit, heliocentric or some other orbit, or whether it's just the stars or like the galaxies at that is kind of zooming out, then that would be on some kind of a Cartesian plane that we've enabled for the night sky. I don't know what you call it. You just call it the night sky, I guess. And then when I look at biology, or like let's talk about the brain in general, it seems like I think we're in a preliminary phase here. We're starting to think about cortical columns, and I don't know, maybe there's something there. It looks like there is, but I'm not sure. I'm not an expert on brain sciences. Same thing, like we're slicing through, literally slicing through, and like I guess if you go back far enough, philosophers would think that there's kind of like a spirit, and the cognitive functions are controlled by perhaps different parts of the body, but we've realized over the course of the past couple of decades, if not a century or so, that predominantly, overwhelmingly actually, the functions in a physiological and cognitive sense are entirely controlled by the central nervous system, with its periphery as the extension of the central nervous system, with the nerves and different kind of nerves, lymphatic and the other nervous system. Like basically, the neurons are controlling all the functions, and well, obviously synapses is a part of that. More synapses. Well, what I'm trying to say is, even in that realm, we're leveraging the Cartesian plane, and we're going narrower and narrower and deeper in order to be able to understand what's going on. So maybe we'll perhaps go down to the level of cells, and we're going to be able to see like what the communication between the cells is really like, because the memories are encoded in cells. Neuron is a fairly large structure. You got 100 billion of those, and then you got trillions, tens of trillions, perhaps hundreds of trillions of synapses. I don't know how many we have. I think 100 and I don't know how many synapses there are in an adult human brain. But yeah, it might turn out that we actually do some kind of fake grid or Cartesian plane for memories encoded in cells, and then work on trying to figure out what's going on between that kind of communication. And same with genetics. I think I made a different video about this, which I haven't posted. But when I look at the way that biological, at least in the mammalian primate human body, how the biology functions, with the core focus on DNA replication, and how the DNA is getting coming out of the cell nucleus and making copies and doing the transcription or the translation. It seems like there is some communication layer there, which we may have an understanding of, or we may not, and we're going to learn more about that. And I think, again, the thing that's going to get us the breakthroughs is the measurement, and the Cartesian plane. It seems like a very, very useful tool in order to be able to further make sense out of what's really going on. Now, there's a couple of thoughts before I get into the other model that I've kind of built. So basically taking the plane and just flipped it over, so if it's facing this way, what I'm saying is, well, let's just kind of think of a collection of planes as a layer. So we say, well, these are all the things we've measured in this reality, in a 3D reality, in a classical Newtonian world, if you want to call it. And so we take these the collection of things that we measured and we know about, and we make a plane, and we call it, I don't know, existence. Or reality, or whatever you want to call it. And then that would be the classical layer that we inhabit. And the layer, well, it's not above us. The layer, it is kind of above in a sense, not that you have to look up, but like we are part of a wider reality, which would be a celestial reality, which we're just beginning to peer into. Like, it's not too long ago that we launched Hubble, and then James Webb's going to be launched soon, and we're just like we've only mapped a very, very, very tiny fraction of the night sky, and we're finding amazing and newer things on almost a weekly, if not a monthly basis, with the findings of more and more exoplanets. A lot of amazing things. and also like our place in the universe and like how insignificant our existence is, and then how fragile it is. Carl Sagan, pale blue dot sense. Well, what I'm trying to get to is that the mapping of the celestial reality is also follows a particular, like a series of measurements that are again grounded in placing things in specific concrete areas, which are again grounded in something like a plane which pinpoints the exact location of what's going on, and laws that govern how this universe, this particular universe functions. And then our reality in a classical sense is a very, very tiny part of a wider cosmos. Next layer down would be, I guess, it's not really up or down, it's just the flow of information is what's going on here. But the next layer down would be quantum. I mean, there's many layers in between, so I'm not getting into each one of these layers. So, like right now, it's atomic, molecular, then atomic, and then perhaps nano, and then perhaps femto or pico, whatever comes next, then atto, as in attoscale. And then finally, at some level, the quantum world is there. And I don't think we have the tools or the technology in order to be able to take pictures or actually document what a quark or something in the quantum world looks like. But the way I understand it, my knowledge is very, very, I know nothing about quantum mechanics. But what I hear some very smart, intelligent people saying is that it is a very successful theory. And I don't know what that means, but so I don't know anything about particles and superparticles, mostly superparticles, I guess, in this realm, for me to be able to talk more about the quantum world. But at some point, as technologies continue to develop and the tools continue to develop, we'll be able to peer at the very structured nature of the quantum realities, and perhaps we will begin the chart, the path towards mapping those realities as well. So that's what this other diagram that I drew, it's really kind of posits. If anything, this video is probably for my daughter, just to kind of like show her that my daughter is almost 8 now, so just to kind of show her that studying math and science will pay off. These are very amazing and interesting. I'm a huge advocate of Khan Academy, and I see beauty in mathematical design. I don't know, it's not like it's like they show in the movies. You're seeing like formulas floating in the sky or something like that. It's not like but there is beauty in mathematics, and I am just a student on almost a high school level, but it's just remarkable that how much you can learn and how much of mathematics you can apply in so many different areas. In fact, till we actually get to a level at some point in our evolution as conscious, I think we're conscious, I'm honestly not sure, because it's subjective, but like we'll get to some point perhaps where it's going to be beyond mathematics, but still I think we'll be predicated on designs pioneered in the mathematical realm. So coming back to the mappings as they exist, at least in these realms that we know of, will again find their underpinnings on a lot of math, and there's going to be a lot of frameworks and systems that are going to be developed in order to see what meets the observation, and if the observation is true and it holds true and is peer reviewed and it's mathematically sound, then well, I think that's one of the bases of the scientific principle. How do we know all of this works? Well, observation meets reality. We have observed different realities, and as a species, we've been actually smart enough to capitalize upon some of these observations. The first was probably our place in this solar system, which goes back to Copernicus and Galileo. Although there's reports that actually, I'm not going to get into that. Like where the telescope was really invented, was it in China or somewhere else? But I guess from a functional sense, Galileo was the first to kind of map that and map the night sky, part of what you could see, and make some observation. Copernicus would, I think, the work Copernicus did led to the reality that the Earth is going around the sun. I don't know much about Copernicus, so I'm not going to speak too much. Then Newton was probably the genius. I think Descartes came somewhere in the middle. So I think the work that Rene Descartes did ended up influencing Newton. I'm not sure. And Newton was the legend who is the legend in a real sense, that really just, I don't know, I haven't read any of Newton's books, Principle of Mathematics, or any one of the books he's written, but it seems like Newton was the one who like really is the father in a sense of modern physics, and real science is physics, so he was the father of science in a way. Like you could say Galileo was, but Newton was the one who codified it, like just like in quantum mechanics. Richard Feynman may have written the paper that there's plenty of space at the bottom, but Eric Drexler codified it, and so becomes the father of nanotechnology. So same, I think, correlation between Newton and Galileo, with Descartes perhaps influencing. I think, I'm not sure. But what I'm saying is, like, from that point onwards, just like took off. There was a bunch of other things happening, and from a cultural, societal perspective, invention perspective, with the Gutenberg press. And I made other videos about this in terms of like how Enlightenment really flourished, and there's probably a complex set of activities happening. It was just one thing or another. It was a bunch of things, and they were happening, and more knowledge was accessible to more people. The literacy rate really skyrocketed within like a generation or two. 40% literacy in one single, or between two generations across Europe. So a lot of remarkable things happening around that time. So going off topic here, coming back to the mappings, there's got to be a way to map these different planes, and not in a cause and effect sense, not in the sense of chaos theory or anything like that, but just from the perspective of one thing is part of the other. So now there's different schools of thought at this point. I don't know much about physics. It's like Richard Feynman had apparently this one person that he worked with or was a friend, I can't remember. And there's this one electron theory. So if there really is one electron buzzing back and forth in time, then conceivably everything is just, I mean, you can kind of go and rationalize it from that point onwards. So I'm not sure, but Feynman didn't regard this idea as quack. I could be wrong, I'm not sure. But if that is the reality, then it does kind of begin to explain, I think. It's going to start getting very uneducated, perhaps flaky from this point onwards. But that could explain something like the quantum entanglement, whereby two particles that are separated from each other over enormous distances are still able to replicate each other's spin state. You can put it on the other end of the galaxy, and you flip this one in a certain way, and the other one would do exactly the same. So if information cannot travel faster than the speed of light, then why is that spin state being replicated? That's a good question. Unless it creates some kind of a link through space-time, which we haven't understood. Like, it's not like a linear kind of pathway, or like, because we think of light, like we think of everything in respect to speed of light. So if it exceeds the speed of light, probably not. We're very quick to deny that based on everything we've learned and understand and appreciate, which is valid. But how do you explain the quantum entanglement is the question. I don't know. How do you explain over distances that are way you can take light, like, I don't know, perhaps like take light tens of millions of years to cross that distance. How does the math work here is another question, because to the best of my knowledge, nobody's taken these particles to the edge of the galaxy and measured them. So why does the math say what it says? So the mappings. How will the mappings work? What are we trying to map? And why? These are all good questions. I'm just going to shut the door a little bit. Yeah, these are all good questions. I don't have the answers. I do think that it's like inevitable as we evolve as a species, and as our technology evolves, as computation evolves, that what I'm about to say next is influenced by my views on the technological singularity, and which I believe a very high probability of something like that happening very soon. So as information as information saturates in a sustainable fashion, what's the extent of her understanding, or perhaps the reach of the speed of light. So we're this is gonna start becoming a little bit more abstract from this point onwards. I said flaky, but that was just entertaining the quantum angle, or briefly exploring it, that state or that reality, but or the one's electron theory. But this one is more abstract than flaky, because I believe a lot of research is already underway in order to be able to power newer forms of computation, which wouldn't necessarily be dependent on let's just say realities that and how they existed and how they power computation. So as we're able to again extend the reach and better our understanding, at least in the 6% of the universe that we inhabit, which is an enormity, and it's going to take us could take us a long time at the speed of light to be able to make sense out of it. It's still 6%. The other, I think 96% or so is dark matter, dark energy, which we know not much about based on my understanding. And the 6%, losing my train of thought. Somebody. I don't want to like give it. I started talking about the Cartesian plane, but I'm talking about mappings, but this is not a video about mapping the kind of like cosmic reality or like that's what I'm talking about right now, but that's not the focus of the video, or perhaps at the bottom in a quantum sense, mapping that. But it's inevitable that we're going to end up doing that, I would say, within now and next 30 years, or maybe less, maybe a little bit more. And as we do that, then that extends the reach of our, not just our knowledge, but also our technological capacities, scientific and technological capacities.
There's a place called Love Space.
So, based on the three realities that I posit that the mappings are going to be required for, and like I said, there's other realities in between, and perhaps there's going to be a lot of mapping required in order to be able to bind all of these together in a sense that it works. I guess the analogy, and I guess it's a fair analogy to make, just like the internet is a collection, a patchwork of DNS servers and in a distributed sense, and networks and wires and satellites and very many servers and with different kind of contents and protocols and different kind of languages enabling that protocol, and obviously nodes in between the network. Similarly, there's a lot more complexity between these realities, and as we learn about each one of the individual components and how they're tied together, then that's going to better the chances of trying to figure out how the mappings really work between the different systems. So I think I've spoken enough about what I was going to say. The conversation started with a thought about the Cartesian plane and why I believe it's a very groundbreaking, it's a revolutionary innovation, if you want to call it, in the world of mathematics. And it's again goes back to Descartes and his intellectual / mathematical genius to be able to come up with that insight that puts something like two seemingly, I would assume they were same distance, I'm not sure, maybe some mathematicians always had an inkling that these worlds are connected. We just don't know. But here comes this guy. He's like, "Hey guys, you just come up with a simple thing like a Cartesian plane, and we give it these two axes, and we give it a point. Then when we put this position right here, it maps to a coordinate system, and a coordinate on the x-axis and a coordinate on the y-axis, x-axis, and that is how we're able to pinpoint. And then he ties it with algebra, and you can put a quote like an algebraic, I can't say the word right, algebraic equation on the Cartesian plane, and it still works. And then you can represent a lot of these things in the geometrical sense, and it still works. It works beautifully. And all of a sudden, I guess it's a mind shift at that point where you realize, wow, these things are interconnected, and changing this thing here, it changes that. It's changing this equation here, results in a different kind of a shape here, and a whole variety of other things that we have clearly witnessed since the time this discovery or invention, like this breakthrough, or the Cartesian plane, since the time the Cartesian plane did arise. From there, I went into at least three realities and how I'm sensing or perceive them, and I posit that there's going to be many different mappings that are going to come about in order to be able to further understand and measure these facets of realities. So whether you kind of look at it as a sub-reality, up, down, or whether you look at it, however you look at it, even if you look at different slices of space-time, and or in a multiverse sense. Tell my computer was going to go to sleep. However you look at it, one is part of the other. Even if you look at space-time not as something that is uniform, but a patchwork, a collection of particles, really, that are intertwined, for lack of a better word. So if you have something like a quantum foam that is potentially entangled or intertwined with some other kind of quantum foam particle somewhere else in space or in time, I don't know what time. I have a tough time wrapping my mind around time from the perspective of physics. Like space, you can just say your space, you expand it, right? You can expand it faster than the speed of light, so that's fact, by the way. I think that's fact. And why is that the case is an interesting question. If nothing can expand or go faster than the speed, how can space expand faster than the speed of light, right? And then the whole question about quantum entanglement is, I gotta make friends with a physicist. But what I'm trying to get to is that however like there's a point I was trying to get into, up, down, different realities, but if these particles are really entangled and information can flow from one place to another potentially faster than the speed of light, then is everything connected? And if it is, then what change, how do these change manifest in some level? And as always, the ultimate question, how can we use it for our benefit? Because that's what we've done as a species, which has improved our chances of survival in the short, mid, long term, and that's what we'll probably continue doing. Quote from Carl Sagan comes to mind: civilizations either become spacefaring or they become extinct. And I'm hopeful and optimistic. I was just watching one of Carl Sagan's interview with Charlie Rose over the weekend, and actually it was one of his, I think it's the last interview he conducted. Yeah, Carl Sagan. And I was watching another interview of him too. Or sorry, somebody talking about how influential Carl was in their life too. I just did a recap because what I'm about to say next, then I haven't had any time to think about this. It's just kind of, but there's no doubt that the Cartesian plane is one of the, in my opinion, one of the most groundbreaking, or the way I sense it, very profound innovation or insight, if you want to call it that. However, and like I've spent 40 minutes talking about how crucial and again groundbreaking this insight has been, and how useful it could be in terms of mapping how information is different, it's flowing in the different constructs, realities. That being said, considering how influential this way of thinking has been, I think it also has a cost. So I gotta think about what I'm about to say next. I think because the model has been so successful, as a species, we have a propensity to be able to overuse, I think, that word works a lot more, which may put some limitations on how efficiently new knowledge can be gathered in a future sense. Well, what do I mean about this? Well, there's the brute force mechanism, and there's a nuance mechanism, and there's a nuance mechanism that employs the brute force, and the brute force mechanism that employs nuances, a lot of different realities in the middle. I don't know where what I'm about to say next sits, but an overwhelming reliance on leveraging constructs that have evolved out of something like a Cartesian plane kind of puts limitations on let me back up. It just kind of, I think, conditions us to focus very linearly, and maybe that's not a bad thing. Maybe it's to keep going deeper into subject matters, and once the technology is enabled, or it reaches a certain state whereby the scope and the range of that application can be expanded hopefully in a sustainable way for us and potentially other conscious beings across the galaxy at least, then you just increase the scope of your known knowledge set in that way. So I'm not saying it's a good thing or a bad thing, but and maybe I gotta think about this a little bit more. I just don't, a lot of my thoughts on these subjects are, it seems they may seem very alien because I didn't go through a traditional schooling system, and but when I do stumble across something like this, I'm like, wow, like who is this guy Rene Descartes? And it's like I kind of try to map like everything that, like I share some of the examples towards the beginning of this video, like it all traces back its origin back to what Descartes pioneered or did. But what I'm saying though is that perhaps what I'm trying to say is that the Cartesian plane, if it does come at a cost, then the cost maybe a subconscious rewiring of our cognition in order to be able to focus more on the tree as opposed to perhaps looking at the forest and then focusing on the tree, if that makes any sense. And maybe all of what I'm saying is going to be irrelevant because we're going to have circuits made out of light, then they're just gonna spread everywhere and make sense out of everything using deep learning. And we're just gonna all sip pina coladas on Mars, and Venus is gonna be terraformed, and I'm just gonna call the Uber to just be with my friends and my daughter at my cottage in all three locations, and more, because O'Neill colonies are gonna be there too, or Stanford tours. Or it's gonna be like Star Trek, where I just beam myself up. My biophysiological and my cognitive self is recreated at the source of the destination, which again is going to be predicated on something like the Cartesian plane, because you don't want to beam yourself up in a different dimension of space or time as a problem. So the Cartesian plane is again really important. What I was trying to say was going back to I don't want to speak too much. I think spoke 40 minutes about the importance. This is gonna I think the Cartesian plane, though, if one of the costs, if it comes at, it's to kind of condition the mind or the brain, both mind, brain, to kind of think more linearly, which may, I don't know what this, the problem needs to be defined in a richer context. I don't even know if it's a problem, if it ought to be categorized as a problem, because if it's not measurable, it probably doesn't exist. But is that true, is the question. And that's a very loaded question, because just positing that question in an unenlightened setting could probably be akin to opening yourself up to a lot of things that are ludicrous. But what I'm saying is, I'm losing the essence of what I was trying to say, is because it's going in a very different area, which I didn't. What I'm saying is that how do we still make the breakthroughs and the discoveries in really, really targeted areas, and go deeper in subject matter, but also find the correlation and the interlinking between different realities or subject matters at the very least. I think that's more of a question in the realm of cognitive computing. I don't want to go into solution mode, because I made a video about books talking to books, which is really, I shared 3 things in it: that you've got to have the environment, and you have to have the ontology, and anyway, so but what I'm trying to get to at this point is, this is kind of making me think about search going into discovery, and then discovery is going to evolve, so it's going to become a thinking, conscious machine, and the machine intelligence obviously can be scaled a lot more. It can be just because of the architecture and the design and the resources can be scaled in a more quicker fashion. Losing the essence is going in an more abstract. I'm starting to think about things in a multivax kind of a sense, in an Asimov sense, that we're just going to be able to posit questions to a construct, and based on the extent through which that construct has spread through its computation functions and its ability to make sense out of that reality. So this human and machine collaboration, but the gradient by which you measure that seems to blur as more and more time passes by. The question is, this is again going in a very different area, like, will higher forms of intelligence always be created? Probably, if that's the testament of evolution for the past, I don't know how long evolution has been on this planet, a couple of billion years. Pyrocorite, eukaryotic, adopted technology in its being, started like synthesizing energy as part of its core, sexual reproduction happened, and then you have a lot of time passing, like perhaps a billion years, and the primates evolved in the past 60 million years or something like that. From the shrew, the Purgatorius, it evolved to Lucy, and well, there are many different branches, and the neocortex grew in size, and then the human appeared at some point in the span of those, after 60 million years passing, and the neocortex grew again between Lucy and the modern man. I think it doubled, and then from there till now, whenever the first modern human emerged, you got to read. I got to read *Sapiens* by Yuval Harari. You'll understand. But now the thing is going to expand again, and the machines, in my opinion, will have an innate, it's in their benefit to keep life evolving and leverage the benefits that the previous construct's power, because in and of itself, intelligence just requires, well, generally speaking, energy, or real power is computation, so it doesn't have an inherent need for space or energy, so to speak. The door. It's off topic, going in the realm of evolution, restraining yourself, coming back. I was talking about the Cartesian plane, and if there is truth in what I'm saying, even though it's presented in a very, very abstract, past the 40-minute mark, so it was 13 minutes into what I'm saying, something like that. If there is a weight to be associated with what I'm saying, that the Cartesian plane, although extremely useful, has a cost, if it is true, if that's a big if, then what should the solution to that be? And why must you have that solution? This, again, it's a big if. So the focusing on the why of that problem will posit that whether an answer to the question is needed or not. Excuse me.
Well, in terms of Occam's razor, the simplest explanation is the best. So in that, if you should be using, again, it's a big if. Again, if it is condition, it's got to, ironically, you've got to have a quantitative construct to be able to deduce whether something like that is happening. And how do you do that? I don't know. But I guess it's always kind of healthy that a sample size of a population is doing something different. And like, how do you do that though? Like, if everyone's doing the same thing, then, like the saying goes, nobody's thinking, or if everyone's saying the same thing. But like, so we have a society where it's a very, this is, I guess this is a philosophical question more so at this point versus anything else. But should there be a group within a sample size, within a population, in a statistical sense? You have a total population, and then you have a subpopulation, which you call a sample size. So you have n, and you have the n minus 1. So this would be the n minus 1 in this case. But if the sample size doesn't do what the majority is doing, then how do you ensure that the sample size, I'm now thinking of it from a social, ethical perspective, which is always important to do. You have a group of individuals. I'm not saying train them as Luddites or train them as, or not train them, or bar them from training themselves. I'm not at all saying any one of these things. The ethical way to do this is to have amongst us a group of individuals who are not preconditioned with any idea, but who are given all the resources, which I think inevitably is the future of education. We're again going in a different direction. It's inevitable that education is going in a completely self-directed path in a very short amount of time, and going forward, you're still going to have teachers, but they're going to be AIs, and you're going to still have assistants, as in teacher's assistant. They're going to be AIs. So, and it's already happening with narrow AI, with the work like Ashok Goel is doing with his teacher assistant running on top of Watson. So you can Google this. But what I'm trying to say is that if you have a sample size who have not been conditioned with certain ideas, then how they wrap their mind around some of these same problems that people who are part of the majority of the sample size or of the population, the way they wrap their mind around will be very different from how these minds have been conditioned, generally speaking. However, again, there is that social and this is an ethical question at this point. So, what I guess it's important to give an example at this point. My battery is running out of juice. Battery's running out of juice. Yeah, I had a cold over the weekend. So it's probably impacting my cognition. Laptop's running out of battery. So I guess the example in this case was like there was an Indian mathematician. I was just watching a documentary on him over the weekend because I got a badge on Khan Academy for accumulating a certain amount of points. And the name is Srinivasa Ramanujan. I hope I'm doing justice pronouncing his name. Srinivasa Ramanujan. I'll put a link to his Wikipedia page on the description of this video, although I don't want it to be focused on Ramanujan. So Ramanujan was a self-taught mathematician, from what I gather, and there was a very well-known English mathematician at that time. His name was, I believe, G.H. Hardy. I'm trying to recall it from memory. Hardy, let's call him Hardy. That's his last name. And I think he was one of the best mathematicians in the world at the time. So Ramanujan, in his mid-20s, I believe, sent a letter to Hardy. And after a couple of back and forths, like, he sent some of the work he did, and one of the best mathematicians in the world was so impressed by the work that Ramanujan had did that he invited over. So there was some initial thing, and Ramanujan couldn't go because of his, I believe, his religious beliefs, but there was a concession made, and eventually he did go to England, and then World War II happened, and unfortunately, like all of these things, all of these, but what happened, like after, like Ramanujan got seriously ill, and he died, I believe, when he was 32. He died very young. What I'm trying to say is, it doesn't look like Ramanujan came from a standard population set. So in India at that time, there would be a standard population, and as part of the standard population would stay that, like, as part of the designs, kids would go to primary and then secondary and then higher ed, and then from that onwards, perhaps a PhD in mathematics. But what I'm saying is that that's not how he did go through the school system, but he mostly focused on math. So you can say, well, that's Montessori then. But he wasn't in the Montessori system. He just did what he really liked and was passionate about, which was mathematics. And he was obsessed with it. And the examples that Ramanujan went with, he solved most of the problems by looking at the examples. And he so didn't really have a lot of the fundamental frameworks and whatnot. It wasn't completely developed as part of his mathematical abilities.
Thanks, Joe.
So I think I'm gonna run out of juice soon. But when Hardy met him, he was kind of faced with a dilemma. Hardy wanted to still retain the passion and the intensity Ramanujan brought to his work, but at the same time he didn't want to teach him the framework or the basics in a way which would impede his passion and intensity. But I think Hardy was still, and there was another gentleman, they were still able to do that teaching or some of the enablement of the frameworks in a way that it just worked. So what I'm saying though is the approach was very different. So Ramanujan's approach was very different, and we don't know what would have happened if Ramanujan had lived for another 30 years or 40 years. We have no idea. Just like we have no idea what breakthroughs and inventions Alan Turing would have come up with if he had lived for another 30 or 40 years, or any other brilliant mind at that. But I guess going back to what I was saying about the population and the population subset, maybe there is a portion of our population based on some metrics, perhaps biometrics or psychometrics or some testing, that we determine that a group of us will tackle things on their own, and they're going to be provided unlimited opportunity to do that, conceding, in my opinion, realizing that eventually everyone will be going that route. But how do you sustain that going forward? And that's this is kind of interesting. That's where the conversation becomes interesting, because entertaining that very reality also posits that you entertain a reality whereby super ridiculous realities or ideas have also to be tolerated. Maybe not, but losing the essence of what I was trying to capture here. Maybe I gotta do this again. Cartesian Plane is a successful model, but I guess what I need to think about is Ramanujan and how he was a self-taught mathematician, and like how can we enable, like imagine if we just were able to enable 10,000 Ramanujans across the world, which I believe is a very realistic goal considering the ways some of the technologies like Khan Academy are evolving. It is almost like, I was somebody had to do the probabilities and really come up with an answer to that, but it's inevitable something like that would happen, as in more individuals were on a path to become someone like a Ramanujan or like a mathematical genius would come out of a construct like a Khan Academy, because you're talking about probabilities. If you have a school like Princeton or I don't know, some others, Berkeley, which produces some of the top physicists or mathematicians at that, then there's a set of realities that power that construct. And the probabilities are low because only so many people can go through these institutions, and you come out, and the probabilities are quite impressive. That so there's only a couple handful of perhaps hundreds of people are going through these institutions every year, and it produces a Nobel laureate every 5-6 years. It's pretty remarkable. But now you think about something like a Khan Academy, you got like tens of millions of people using this system, and within the sphere of the 20%, if you go granular and granular and granular and granular, you're going to find within those 20%, there's going to be a fraction of those 20%, very, very small percentage, who's going to be the elite performers on this platform. And not in a meritocracy sense, but like somebody who is perhaps good at one area of mathematics versus overall, or a bunch of them, and so maybe I'm negating myself because this is kind of like a quantitative metric in order to be able to come up with increasing the probability that we're creating more Ramanujans or mathematical well, I'm losing the essence. Maybe I should just keep it to the Cartesian plane. Very useful tool. Will be useful when it comes to further mapping the different realities and how they bind together, if they do bind together, which seems like they do, I'm not sure. But at the same time, the other thing I was thinking is if there is a cost to the Cartesian plane, so yeah, this kind of makes sense. It's kind of useful that I did this talk. It helped me flesh it out. If it does come at a cost, if it does, then my question was, what is that cost? Focusing on the if itself, put some weight around it in terms of defining the why, and then work towards figuring out if a portion of the population will go the route of self-learning, and if they do, how do we ensure that their quality of life is maintained as they do that? The net intent would be to get somebody like a Ramanujan, and also to keep ourselves open to the possibility that in a weird Zen-like sense, there may be ways to kind of dance with the Cartesian plane, so to speak. I think that's a good way of looking at it. Dancing with the Cartesian plane. I'm glad I made this video. I don't know if it's going to be public, but if you did watch it, then I would like to know if this makes sense. It just sounds like a huge, like totally abstract set of concepts. Well, if you did watch the whole thing also, then you would appreciate that the first 40 minutes were focused on appreciating the one breakthrough that Descartes came up with and how useful it has been for humans and continues to be. And if you have thoughts about the remainder of the 29 minutes, then I would love to know more. Thanks. I'm serious. I'd love to know more. Thank you.